Section 7.6, Complex Numbers. In this problem, we have the square root of negative 25. But remember, we cannot take the square root of a negative number. So we can factor that, and that is actually the square root of negative 1 times 25, which can be rewritten as the square root of negative 1 times the square root of 25. The square root of negative 1 is our imaginary number, and we call that I. The complex number form is A plus BI, where A is the real part and B, which is your number with I, remember I is the square root of negative 1, is our imaginary part. And we consider the real parts like terms and the imaginary parts like terms. But together, those are not like terms. We could not add those. But we can add complex numbers by adding the real parts and adding the imaginary parts. For example, I have two complex numbers, 2 minus 5i plus 1 plus 3i. I can add those together by adding the real parts, 2 plus 1 is 3, and adding the imaginary parts. Negative 5i plus 3i is negative 2i. Final answer, 3 minus 2i. When we multiply radicals that have negative numbers underneath the radical sign, we must first pull out that square root of negative 1, which remember is I. So we get I square root 2 times I square root 7. Now we can multiply them. I times I is I squared, and square root 2 times square root 7 is square root 14. Now remember that I equals the square root of negative 1. So if I square I must square the square root of negative 1. And the square cancels out the square root, which means that I squared equals negative 1. So in my answer here, I squared times square root 14 really is negative square root 14, or negative 1 times square root 14. Another example of multiplying complex numbers is where we have to FOIL. 5 times 3 is 15. 5 times negative I is negative 5i. 2i times 3 is positive 6i. And 2i times negative I is negative 2i squared. Now we need to combine like terms. Negative 5i plus 6i is 1i. And negative 2 times I squared, remember I squared is negative 1. So now we have negative 2 times negative 1, which is positive 2. 15 plus I plus 2. Combine our like terms, 15 plus 2, and we get 17 plus I. Remember to keep it in proper form. The real part first, the imaginary part second. An example of dividing complex numbers. It is improper to have I in your denominator, just like it was improper to have the radical sign in your denominator. So we need to multiply the denominator by what we call the complex conjugate. Which means we have the same terms, but the opposite sign. And if we multiply the denominator by that conjugate, we must also multiply the numerator, which means we need to FOIL both the numerator and the denominator. So starting with the numerator, 1 times 1 is 1. 1 times negative 2i is negative 2i. Negative 3i times 1 is negative 3i. And negative 3i times negative 2 is positive 6i squared. In our denominator, we multiply 1 times 1, which is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i. Notice how those two will cancel out. And 2i times negative 2i is negative 4i squared. Remember, I squared equals negative 1. So let's rewrite this, and we're going to combine our like terms here. 1 minus 5i plus 6 times negative 1. In our denominator, negative 2i plus 2i cancels out. 1 minus 4 times negative 1. Notice how we no longer have I in our denominator. Combine like terms, 6 minus 1, 6 times negative 1 is negative 6. 1 plus negative 6 is negative 5, minus 5i. And negative 4 times negative 1 is positive 4. 1 plus 4 is 5. We can reduce this by factoring out a 5 in our numerator. If I pull out a 5, that's going to leave me negative 1 minus I over 5. And the 5's reduce out. Final answer, negative 1 minus I.